In the first place, the kidneys receive a large volume of blood, more than a quart per minute. It is unthinkable that the infinitely large number of molecules contained in the plasma of the blood can be handled by running them single file past a checkpoint. Actually, only a part of the plasma that enters the kidneys at any given time is scrutinized on a particular trip. Even so, there is provision for making a check on all the body's blood plasma at least every half hour, and as a result of this check, the quantities of the substances dissolved in the plasma and even the water which carries these are reduced or retained as meets the body's best interests. The kidneys handle their task very much as ticket checkers at a large auditorium handle a crowd of people as they enter the many turnstiles and are directed to their seats in various sections. Each kidney contains 1 million neurons, each neuron being constructed like a complete piece of equipment in a chemical laboratory. 1 millionth part of the work of each kidney is handled by each neuron. And, and with 2 million neurons operating in the two kidneys, the work goes forward with remarkable dispatch. The neuron consists of two essential parts, the renal corpuscle and the tube, tube, tubule. At the center of each renal corpuscle is a turf of blood capillaries. This is surrounded by a delicate funnel-like structure designed to collect the fluid which seeps out of the blood capillary. This funnel-like capsule makes direct connection with the tubule, which, after following a tortuous course, opens into the kidney pelvis. The blood vessels which bring fresh blood to the kidney and branch and rebranch until finally there are about 1 million branches, one branch for each neuron. It is one of these tiny arterial branches that pours its blood into the capillary turf located at the center of each renal corpuscle. The capillaries in the turfs are uniquely designed so that there are minute windows in their walls through which water and other substances, if their molecules are not too large, may pass. The molecules of protein in the plasma and the blood cells are too large to squeeze through these openings. A considerable amount of water carrying all of the dissolved substances contained in plasma except protein filters out the capillary tuft and is directed by the funnel-shaped capsule into the tubule. This fluid is not urine. It is much more dilute than urine and is called glomerular filtrate. In an average adult, the usual amount of glomerular filtrate produced each day is about 180 quarts, 170 liters. As the filtrate passes through the tubules of the neurons, most of the water is reclaimed, as are also the molecules of substances which are still useful to the body. The process of reabsorption which takes place in the tubules is much more remarkable than the process of simple filtration that occurs in the renal corpuscle. For in the tubules, a selective action takes place by which certain molecules are reclaimed while others are permitted to pass on into the kidney pelvis and then to the bladder. The tubule of a neuron runs a tortuous course. If it were straightened out, the tubules of just one neuron would measure a little more than 1 inch, 3 centimeters in length. In proportion to the microscopic size of the tubule's diameter, and in comparison to the size of the renal corpuscle, the tubule's length is very great. In fact, when we consider that there are two